Hello viewers, my name is Ashok Sen Gupta, working as an assistant professor in School of Management Sciences, Lucknow. Today my topic of discussion is nodes and arrows. Uh, in last previous lectures, I discussed about the network diagram. I discussed with you about the concept of network diagram. So, by following this network diagram, I just in today's session we discuss about the concept of nodes, why we require nodes and arrows, how they work for proper network diagram, because it is a graphical representation. Network diagram is a graphical representation of the workflow, and with the nodes and activities arrows we clearly defined these chart on a paper, which helpful to analyze the things to the for the different stakeholders, which are whom are related to, associated with and with a project. So, today our topic of discussion is identifying the nodes and activities. Identifying the nodes and activities. Activities or nodes in a project management team that refers to precedence diagrammatic method which use boxes to denote schedule activities, which use boxes in schedule activities. So, like this, we use boxes for schedule activities. These various boxes or nodes are connected begin to end with arrows to describe logical progression of dependency between schedules. So, like this is a one box, this is another box, these are the activities and both box are connected like this. So, it shows one box is depend on another box, it shows one box is independently working. So, nodes and activities are represent on the diagrammatic form and which connect the boxes with arrows. Each node is coded with a letter. Each node is coded with a letter or number that correlate to an activity on the project schedule. Each node is having a number like A or 9. These numbers, these alphabets, these numbers help to understand the activities and they are correlated with each other. They are correlated with the activities. Typically, an activity on node diagram will be designed to show which activities must be completed in order for other activities to commence. It means it shows which activity is followed by another activity. It shows activity must be completed in order to activity commence, like A is a activity and B is another activity. This line, this arrow shows when A finished, B started, or like this, if from when A finished, B or C started, or when B and C finished together, then D started. That means, in this condition D cannot be start, D activity cannot be start until both A and B have finished, both A and B has finished. So, activity node diagram will be assigned to show which activities must be completed in order to commence the other activity. This is refers to finish to start. This is also known as finish to start. Preceding meaning on one activity must finish before next activity. As I told you, one activity must be finished before starting of another activity. In a project there are various things, like we take example, simple example of a project of road construction, a project of road construction. Until and unless the road is properly level, until and unless the road is properly leveled, till then we have to wait for the next activity, that is the upper layer. So, this is a road, okay, this is a road, this is the road. So, first task is to make it level. For leveling we need to fill this one. So, until and unless we filled the digs and make it properly leveled, we not able to put the upper level or concrete layer to make a proper road, to make the proper road. Okay. So, start to finish proceedings reflect one activity must be finished before starting of the work. In this diagram, here I just written there in the diagram below, activities A and D must be done. So, activity B begin. It is possible for the creating a variation. So, first we move to the diagram. Let us see here, this is beginning, this is beginning, and from beginning we have three activities, we have three one activity is A, another is D, and third one is B, F, sorry, third one is F. D E is followed by D and also A. It means until both activities A and B, A and D not completely finished, till then E not will start, E will not start, E will not start. So, E is depend on both of them. Here G is depend on F, A is connected to B and E. A is connected to B and E. It means B and E both started when A completed, both started when A completed. Then when B completed, when B completed and E also completed, the work C will start. the work C will start, and finally all activities come together at this point. So, all activity come together at this point. So, see here the boxes are the activities, and these are the followed diagram. Arrow shows moving forward, and here we see A, B are related to each other. B is dependent on A, E is dependent on A and D, G is dependent on F, C is dependent on B and E, and finally we reach the end point. Finally, we reach the end point of the project, and so this is the end point. So, here we complete all the work done. An activity node diagram can be used to provide visual representation of network logic of an entire project schedule. It gives the network logic to the entire project schedule, or it can be used for any smaller section of schedule that lends itself to bring represented as have a defined beginning and end. So, either it is a big project or a small project, we can represent the things with the help of activity node diagram to show the movement of the process. Activity on arrow. It is an networked dramatic technique in which activities are represented by arrows. Activities are represented by arrows. The start and end of each node or event is connected to an arrow. Start or end of each node is connected to an arrow. Between two nodes lies an arrow represent the activities. So, these are the nodes. So, these are the nodes and this is the arrow. These are the nodes and this is the arrow. So, between two nodes lies an arrow that represent the activities. So, activity on arrow is represented by nodes and arrow, and nodes is like this and this is an arrow, and it shows the activities. It shows the activities of which activity is going to be held. Therefore, activity early start represented by ES, activity early start is represented by ES. It is the earliest time that activity can start. It is the earliest time, like earliest time ES. It is earliest time that represent the starting point of the any activity. Early finish, it is the earliest time which include this time plus duration plus activity. This time plus duration, like started at 3 and take 6 hours of duration, then finish time is 9. So, earlier finish EF is earlier starting point plus duration time, earlier starting point with duration time. So, earlier finished is a combination of earlier starting point and duration time of the project. Earlier late finish LF. LF is latest time that activity can finished. It is the latest time LF that can be finished, and late start means latest finish time minus duration, latest finish time minus duration. In previous slide, let us see, move to the previous slide. Here ES is EF equals to ES plus duration, but here LS equals to LF late finish minus duration. Last activity is floating time. The floating time, the float for the activity is the amount that is duration can skip without causing the project delay. An activity with a 0 float is a critical path. Activity with critical float, the float, I again repeat, the float, a float for an activity is the amount for that that is the duration can skip without causing the project delay. We can skip, that is floating time, we can skip that time. See here, this is starting time of the project, okay. This is floating time of the project, this is the floating time of the project, and this is starting time of the project, this is a finish time of the project. On this arrow we add activity duration, and this arrow we add activity duration like 6 or 9 or 10, whatever the duration, and activity name is given by, you can give the name or denoted by A or B or C, whatever you want. So, this is nodes, these are the nodes and these are the arrows. The nodes gives the starting time and finish time with floating time. In AOA diagram, the activity name and the activity duration are specific on the arrow between nodes. Then each nodes contain 3 numerical values. Each node has 3 numerical values: a starting time, finish time and the floating time. So, each node, if this is the node and its starting time is 6, finish time is 8. Okay, finish time is 8. See, in this example above, we take initial starting time 0. We take initial starting time 0. 0 से शुरू हुआ, starting time 0 and add duration. Add duration. We take 8 hours, like 8 hour journey. 8 hour journey 8. Here this is 8. Then finish. Then next activity add 8 hours. Our next activity added 8 hours. That means we started our journey, reached a certain destination at after 8 hours. The next step will started only after when we reach there. So, the next node started from 8. So, started for point for node, this node, that is B node, C, D, A. Okay. So, for A starting is 0, for B starting is 8 and this is 5. So, for C starting is 13. So, A1 get standard time for the second node. This then we process by adding duration on activity. Clear? So, when any activity is started, we add the duration to get clear picture at how much time is take for the next activity. These are the activities. Okay, these are the activities, these are the nodes, and these are the arrowheads. If it started with 0, 5 hours take, next is 5, then it is 6, next is 11, next is 11. So, activities are depend on each other, and they are representing the various time duration process. With the backward pass, the the end node started time become the finish time, and the backward pass process by subtracting the duration of the activities lead by the ended node from the end node's finish time to arrive at the finish time of the preceding node. When we move backward, we deduct the time. As with the NOA approach. When a node has several successors, the smallest successor finish time used on the base of node time. The smaller successor is based on the node time, following by the diagram C. When we move further, when we move this direction, okay, 0, 3, then 3 to 2, 3 plus 3, 6, 6 plus 10, 16, 16 plus I am moving here, 0, 8, 8, 8 plus 5, 13, 13 plus 9, it is 21, and this is 20, 0 plus 5, 5, 4, 9, and then 6, that is 17. So, our time, this is the differences. Look, 16 plus 9, 7, 8 plus 5, 3, 8 plus 8, 0, 13 plus 13, 0. So, and here look, 8 plus 5, 13, this 8 plus 5, 13, and 13 plus 9, 22. So, we need a maximum time, we find the maximum time. So, here we write the 22. Then when it is backward process, this is last, less the duration, 22 minus 16, 16, 22 minus 16, here is 16, 22 minus 9 is 13, 13 minus 5 is 8, and 8 minus 8 is 0. So, this will be the path. 22 minus 4, 18, 18 minus 10, 8, 8 minus 3, 5, and 8 minus 3, 5, and then this 3. So, therefore, it is not be 0, therefore, we will not include this one. So, when we calculate the maximum path taking, we are taking about the when we started, we need to check where when in which path the starting point will be 0 and which path the starting we take the maximum path. So, the maximum path is like this. So, 22 minus 13, 9 is 13, 13 minus 5, 8. So, this is a backward process and forward process in which we have a starting point plus duration, last point, last finish and minus duration. So, this is about the arrow node diagram. Hope you understand the topic about the arrow node and how to we join nodes and arrow for making proper path, for making proper path. We will do the further discussion in our next topic on the arrow nodes or the PERT diagram. Thank you for watching this video.